But right now, we have a really feel-good story that's come out of South Africa. A team at Wits University has managed to develop a prosthetic hand that uses brain signals to control movement. These kinds of prostheses go for about 150,000 rand. But they've managed to develop one using 3D printing and sensors as well. And they expect that it will cost about 2,000 rand. I mean, that brings down the price in a huge way. It cuts down the price for this prototype will cost less than 2,000 rand. So that's a great reduction on this kind of prosthesis. And you can only imagine the kind of impact it will have on people in need. So we'll be joining Charles Beukes, who is a trustee of the Amputee Club of South Africa, just to give us a sense of the impact this kind of development can have on people who need prosthesis. But first we speak to Abdul Khalik Mohammed. He's a lecturer in the Department of Electrical and Information Engineering at Wits University, and along with other PhD students, they've managed to develop this robotic, or this prosthetic hand, I should say. Good afternoon, Abdul. Thank you so much for joining us.
Afternoon, Zani. How are you?
I'm good, thank you. So excited about what you've managed to do. So this project has taken, 3 years or so to get to where it is today?
Yes, this is the 4th year that it's been running for, and we basically been building on for the last, since 2014.
Yes. So what is it that you've managed to achieve? Just give us a sense of exactly the prosthetic hand that you've developed.
Okay, so we've basically managed to build a prototype robotic prosthetic hand which has been 3D printed at this point. So we've managed to integrate the prosthetic hand itself to the body by using signals from the muscles on the upper arm.
Signals from the upper arm?
Yeah. So you've got electrical signals that emanate from the muscle. Mm-hmm. And then we basically saying that if you've got a person who's got an amputation and they don't have a forearm anymore, then they need to use some sort of muscle activity from the upper arm, which is still intact. Mm-hmm. So then we basically put some of the electrodes, similar to those tabs that you put on when you're measuring the heart. You put those onto the upper arm. Mm-hmm. They would measure the electrical signals from the upper arm, and then we'd translate those signals, try and figure out what is the user actually wanting to do.
Yes.
And then basically then control the hand to grip, so we can grasp specific objects like balls or a mug or a pen.
Oh, so as fine as a pen?
Yeah, so last year we've managed to get it to grip a marble, a pen. So the functionality is basically there for this prototype hand, and we've managed to get the basic functionality working at a very low cost.
Oh, wow. And let's look at that, because it's got the sensors. It's working like some of the best prosthetic hands in the world, and yet the cost is really low.
Yeah. So I wouldn't say it works as well as the other prosthetics have working, compared to the international standards. Because it's still a prototype, so it hasn't gone through the rigorous testing. It's not as robust yet. Mm-hmm. We don't know how well it's going to work in everyday life, so that still needs to be developed. Mm-hmm. But the product itself, it shows the functionality, so it can grip, it can sense the signals from the muscle. And now what we're doing now is we're trying to add in some sensory feedback via vibrational motors.
Vibration motors, you say?
Yeah, yes. So in a similar way, you have, the vibration on your cell phone. Yeah. We'd use little motors like that and attach those to a part of the body that's still functional. So it might be the other arm. Mm-hmm. And then those would move and they'll vibrate in relation to the sensors on the prosthetic hand. Oh, so the user would get a sense of what they're feeling.
Yeah, so a soft grasp or a hard grasp, or this, even does it tell us about the texture of what you're handling?
Well, at the moment we're only looking at 4, so it'll either be soft or hard.
Okay.
The temperature, texture, friction, those kind of things would need to be added on probably at a later stage.
Wow. So the role of 3D printing, I mean, this technology has disrupted so many other industries. Is that what has brought down or would make this much more affordable?
Yeah, that's one of the main reasons for it. So we don't have a major cost to the actual structure of the prosthetic hand. I mean, most of the cost is not involved in the actual structure. So the 3D printing is really cheap. It's really easy to use. You can you basically draw it on a computer and then put that into the 3D printer, and then out comes your product. So there's not a lot of waiting time. There's no costing. There's no expensive material being used. It's lightweight. And it's easy to upgrade and change and experiment with, especially from a research perspective.
Wow. I mean, this is fantastic. It's amazing. You lecture at Wits University, but you're also a PhD candidate, right, in the School of Electrical and Information Engineering at Wits. So the team that you had to assemble, the type of skills that were required in realizing this, what were those?
Okay, so most of the students that have worked on the prosthetic hand itself have been final year engineering students. So they're basically finishing up their degree, and they've acquired all the skills that they need to become professional engineers in the workplace. So they do their final year project, and they're working on a portion of the hand, and they hand it over to the following year, and they carry on working in slowly. So, the range of skills come from electronics, signal processing. Some of them have expertise in biomedical engineering. They have also a very fundamental grasp of mathematics, some statistics, control engineering, microprocessors, and so on.
All right. No, it's
an amalgamation of different skills that the students have had.
So this kind of project, how is it funded? Are you able to give us insights into that?
So some of the funding would come from the the National Research Fund for South Africa, but the reality, and some of the funding has come from the School of Electrical Engineering itself, because the hand itself is not very expensive. We've managed to develop it with relatively low funding.
And who would be candidates? People who would be candidates for this kind of development?
People who've had amputations.
Yeah.
Mainly that's for the prosthetic hand. But then the system can be adapted to an orthotic hand or an exoskeleton, where somebody, for example, who's had a stroke or is paralyzed, or has some sort of muscular disease, they can't use their hand as well as a normal person, or not at all. And then you would put some sort of exoskeleton on top of their hand, and then use the same technology to control this exoskeleton, which would then force their hand to be moved around in the way that a normal person could use their hand.
Right. You say it's lightweight. There's a question about the weight. How much does it weigh?
It's probably about less than a kilogram.
Less than a kilogram, you say?
Yeah, so the 3D printing makes a big difference as well, because there's nothing really solid, or in the middle is a hollow structure. And so we've got many electronics and some motors in there. The motors have been optimized to make the structures quite light. The one thing that we do need to add still that would add quite a significant weight to it would be the portable batteries. But you can get lighter versions of those, like you get in your cell phone.
Well, Abdul, stay with us as we take a break. And after the break, we'll be taking your calls and your comments around this interesting development. It still has some way to go, but I think it's very promising, because so many people go without prosthetics because it is prohibitively expensive. And for this kind of prosthetic hand that uses brain signals to control movement, you'd have to sometimes get it from other parts of the world, which increases the cost to the person. So we'll take your questions and your comments, and we'll also be speaking to Charles Bierkes, the trustee of the Amputee Club of South Africa. We've been chatting to Abdul Khalik Mohammed, who's a lecturer and a PhD candidate in the Department of Electrical and Information Engineering at Wits University. He had compiled a team. He's been heading up a team over the past 3 years. This is the 4th year where they've developed this prosthetic hand. And we join Charles Bierkes now, trustee of the Amputee Club of South Africa, just to look at the sort of impact this sort of development has for those in need of prosthetics. Good afternoon, Charles. Thank you for your time.
Hi, how are you guys?
I'm good. How are you?
I'm good, thank you.
So
incredible to hear such good news and development going on in our country.
Absolutely.
Incredible.
Yeah.
Yes.
So let's start by looking at the work that you do, Charles, as the Amputee Club of South Africa. You're a non-profit organization, and you raise funds for people who can't afford prosthetics.
That's correct. We work in association with a couple of other associations. Our biggest being the Christian Motorcycling Association, Superbike Magazine, and then we have a kiddie site that looks predominantly after the kids that have lost limbs through cancer, which is the Kirsty Watts Foundation. Incredible young girl, suffered from cancer herself and started a foundation, Kids for Kids. So, obviously, again, is because, all of us that work with the association are also volunteer workers. We use a lot of amputees that have been amputated that help us with the things to promote with other people. And again, as I say, it's purely done for the love and just to get people back up and walking.
Absolutely.
We have a very clear thing. Our donated funds are put into a trust. Whoever makes the prosthesis for us, once we're happy with the patient and we're walking with them, and we're happy with it, we will sign it off and the trust pays them. So all the money is donated to us, 100% of it. And then, of course, the funny thing is that we use motorcycles to promote it and to help us to raise the funds right throughout the country. We've done in excess of about 700 odd prostheses over the last 18 years. We've been in projects with the government in the Eastern Cape, which is again a very rural area and very difficult for people to be able to get the funds together, and with the government, with the load that is on them, to be able to get all those people up and walking and where hands are concerned.
Yeah, so what is the scale of the problem as far as accessing prosthetics is concerned?
It's massive because the census, once again, is very sort of limited, and we've had to look at what government is saying and then to try and adapt it to other African countries and our own experience over the 18 years. So we estimate there's about 2.1 million amputees in South Africa. To tell you again is how many arms, how many single fingers and what on that is a very, very difficult proportion. Of course, our biggest thing is diabetes. I think that we're in excess of 70% of people that have lost limbs through diabetes, and it's again the disease that's not sort of rated. If you talk about cancer, everybody gets a fright, but nobody seems to think that diabetes is a chronic disease and kills more people than cancer, and probably most of the other diseases as well. So,
and we continue to hear about climbing numbers.
Yeah, it's let me tell you, it's crazy. And when we're looking at people in the rural areas of KwaZulu-Natal, the Lusiki areas in the Transkei and things like that, the people just don't have the access to the medicines and also the diets that are required. So it's a massive, massive, massive problem.
So what does a development like this mean? Because we know how costly it is. The waiting lists are extensive. So to you, as the Amputee Club of South Africa, what does it mean?
It's amazing because just to give you an idea, Kenny, if you're looking at a completely just mechanical type of hand that is being supplied, you're looking at about 30,000 rand just for the hand. That's not what goes onto the top of it. If you're looking at a very, very basic electronic type of hand that fitted on, there's nothing under 100,000 rand. If you're going into anything sort of sophisticated, you're looking at 400,000 rand. And that's just the hand, not anything that goes with it or anything. And if you have a look at the Road Accident Fund and Workmen's Compensation, where people have lost hands, where a lot of the people do that, they're working in butcheries or on the old days in the farms where they got caught in harvesters and things like that. Those providers are not paying for those. They're just not giving that type of hand. And then even the medical aids. If you have a look at your top medical aids, you'd probably find that the benefit for external prosthesis is in the region of anything from about 18,000 rand to 40,000 rand.
Yeah, which doesn't even scratch the surface. Absolutely. Well, let's hear from Abdul next. Abdul, what is the next step? What happens next? Because we've got a sense of the need. What now? Because you do say that it needs some perfecting. There's some other areas that you want to refine.
So this year we're looking at adding some sort of sensory feedback. I think the next step would be to actually improve the aesthetics of the hand, to do some testing and to improve the robustness of the hand so that it's strong enough to be used in everyday life. It's the right weight, it's the right look. Then to do some sort of research to see how well it will be accepted by people. You know, there's also the social stigma of people with amputees, so the hand needs to work for the individuals. It's not supposed to be designed to scare people. You want to shake somebody's hand, you don't want to chase them away.
So aesthetics.
So we've got basically like the engineering functionality working now. Now it's a case of how do we make it mechanically robust, make it aesthetically appealing, formalize the cost, look at how the cost will be impacted if we manufacturing on this in economy of scale, looking at funding from external industry members. How do we, work with the amputee funds, for example.
Fantastic. Wow. Abdul, congratulations to you and your team. I know you're not at the final stages, but these are great breakthroughs nonetheless. This is to encourage you further. Thank you very much.
Thank you. Thank you for your time.
Thank you. That's Abdul Khalik Mohammed, a lecturer and PhD candidate, the Department of Electrical and Information Engineering at Wits University. And Charles, thank you for your time. And I hope that people listening will be able to support your initiatives because you do such incredible work.
Thank you very much, and I'm looking forward to working with Abdul, and I've got a 14-year-old kid in Joburg Gen that's just been amputated through shoulder, and I'm very pleased. I want to see if we can work this project to help that kid.
Fantastic.
Thank you so much for the time.
Thank you. That's Charles Beekers, the trustee of the Amputee Club of South Africa.